Okay. Pay attention to this too. You can, but you can keep doing it. So, black holes.
Okay, I just got that one. I guess it's that. I got it from the spy content. Red should work.
Nothing. Okay. Black holes. An infinitely small particle that can't be observed with the naked eye because it's so small that gravity is pushing in on itself. Basically, bending space. Say this is the black hole. This is space. It's bending it. It's space-time is being bent by the black hole. And because of that, everything that gets near the black hole gets sucked into its event horizon. And because of how space is bent because of the black hole, because it's down here, it looks like something gets spaghettified. It basically, the matter gets put into a line that seems to be infinitely long, that we cannot measure. Because of the length of it, it is so thin and so long that it would probably be an estimate of smaller than an atom, most likely. But what I want to talk about is how the fact that black holes, their event horizon eats everything kind of like that. Those two gravitational pulls, but that's not what I need to really talk about. What I'm talking about is a black hole is a smaller than microscopic, subatomic sized particle that is so small that it eats every single piece of matter that enters its event horizon. But I want to know what's on the other side. The other side, as someone once told me, John, one of the beliefs is that it's like putting something over a blanket. All the matter gets put into an area that we can't see because it's basically underneath the blanket of reality. But I think one of my beliefs is that that black holes have a second side. And of course, a lot of the scientific community believes in this too. It's called a white hole. It is where all the matter goes because you cannot neither create or destroy matter from nothing. So I believe there is a white hole that spews matter out of it constantly that corresponds to the black hole. Anything the black hole eats will be shot out as pure matter from the white hole. People also believe that that it takes you to a different universe, but that's not true. It will crush you. It destroys, it disassembles your atoms. If this was, say this is just a person with a really big leg, I guess. And they try getting near a black hole. Black hole's right here. Even that size of the black hole, even though it's that small, their matter would begin to basically stretch and enter the black hole if they got close enough to it, eventually consuming them. And that doesn't seem like that they're being just disassembled, but it is, because it won't disassemble like dust. It will disassemble atom by atom. So your hand is right here. This is a microscopic, let's say this is your fingertip. Because of the black hole sucking in your finger, it looks like this if you get close enough to it. But if we go smaller, let's say subatomic scale, where this is the tip of your finger. If you go smaller, it would resemble more like dust being, not dust, but more particles, little like areas of your skin being sucked away if we went subatomic. If we got smaller than that, we would see the atom be compressed down. And that would cause, well, a growth in the black hole's mass, because black hole, they grow in size depending on how much matter they consume. And how dense the matter is. Now, black holes, of course, they're a singularity of sorts, singularity in quotes, because we know how it works to most of our ability. It's a little particle, small enough, so dense, it sucks in everything, light and matter and energy. I'm not positive about if it sucks in radiation, because radiation, I believe, is on a different frequency from the black hole. But I would like to believe that it probably does, most likely, seeing how it sucks in stars. We cannot see a black hole, they're completely invisible. They suck in the light that you see. What we can see is the matter that's still being sucked into the black hole. So when the black hole eventually, when there's no matter in it yet, when it's consumed all the matter, what it would really resemble is something sort of like this from our eye. Maybe a little more like this, with a pitch black center, like the darkest thing that you would ever see, blacker than pitch black itself, blacker than Vanta black. It's sucking in light. There's an absence of light when you look at a black hole. That is because it is sucking in all the matter that is producing the light and well, emitting it. But then how come, if it's eating so much light and so much energy and so much matter, how come it's not glowing like crazy? Because it has all that energy in it. Because there must be another end. And if there's not another end, most likely it just gets smaller and smaller, more compact, to the point where you can't see the light. And of course, when a black hole eats something, what does it do? It gets bigger. So maybe the bigger it is, the harder it is to see the light that's being emitted from the center of it. But just maybe, black holes have another end. It's quite a possibility that we have not proved or disproved. We know that black holes can merge with other black holes, subsequently one of them fusing together and having one of the black holes absorb the other infinitely small particle, basically fusing it, making the black hole not very much bigger, but only slightly bigger. Because we don't know if it's collecting the mass from the inside of the particle, or if it's just overlapping with it and keeping the other black hole in its gravity field, basically. Altogether, black holes are just a microscopic particle, an infinitely small particle that sucks in matter to a point where it's perceived as being extended because of the bend in space that is occurring.
Can I ask questions?
Yes?
Okay. What do you mean when you say it gets bigger the more matter it eats? Because if it's infinitely small, how is it getting bigger?
That's the fun part. The infinitely small particle, it's causing such a strong magnetic field.
Mm-hmm.
It is condensing space itself.
Mm-hmm.
Condensing the matter to the point where it can't be seen.
Yeah.
But the reason it gets bigger is because the more matter it collects, the stronger its gravitational field looks.
Okay.
And the farther out it can absorb matter from.
So it's not getting bigger in scale, it's like the gravitational force is getting stronger.
As far as we know, the infinitely small particle does not get bigger. And if it does, it's by an infinitesimal point.
Mm-hmm. So when you say bigger, what you're really saying is the gravitational force is extending farther.
Yeah.
Right?
The black hole is the gravitational field itself.
Mm-hmm.
The particle itself is just the infinitely small particle.
Mm-hmm.
I'm not sure there's actually a name for this thing.
Okay.
I think it's just the infinitely small particle or the mass that started it off. Black holes form from when a large amount of mass condenses in on itself due to a supernova or the death of a star. Such as a neutron star. Say, here's a neutron star, it's dead, it's cracked all over because it's a neutron star and it's pure neutrons. Neutron stars are so dense. Let's say if we brought a rock from Earth and drop down a neutron star, it would immediately condense and like suck in itself because of how strong the gravity is on a neutron to the point where it will immediately form a black hole. Any questions?
So basically, anytime space debris encounters a neutron star, black hole.
That we don't know that for sure,
Okay.
but we know for a fact that if enough matter gets introduced to a neutron star, it will collapse in on itself.
Okay, so it has to be like enough.
We don't know the specifics.
Gotcha.
It depends on the size of the neutron star.
Gotcha. So do bigger neutron stars require more matter or less?
I would assume less.
In order to form a black hole. Okay.
Well, these are all theories
Gotcha.
because we've never really gotten close to a black hole.
For-
Closest we got was a telescope that that got a picture of it. Fun fact: that picture was right after two black holes merged. So they actually saw it merge, but they could only get a picture of it.
It's probably smart not to get too close.
Yeah. Well, there is a safe distance.
Can we measure the safe distance or like?
I believe there is a way to measure it. Here's the black hole. So it just gets more and more darker the closer you get to the center.
So you said this white hole.
White hole is another theory that's compared to the black hole because it can't destroy or create matter out of nothing. So the matter must go somewhere. It
Okay.
either gets super condensed down into the size of the infinitesimal sized particle that's in the center of it, or there is another area, a different thing that will just spew matter that has been consumed by a black hole.
Yeah.
That will radiate the matter that has been consumed.
Gotcha. Next question. You said it's not in another universe. So you're
That we know of. It is
Okay.
most likely not in another universe, seeing how our universe most likely is constantly expanding. And if we would want another universe, it would have to be so far away that when our universe finishes expanding, meaning there's not enough matter to have it keep expanding, that this would also have to have enough matter to stop expanding.
gotcha.
Which goes into the multiverse theory, which is a completely different theory.
Okay. So you think it's more likely that this white hole is also in our universe?
Yes. Most likely appears in a different universe, most likely a fold in time itself, like a little loop, but smaller than a wormhole. This may look like a diagram of a wormhole, but it's not. It's small.
Okay.
I'm going to say it's smaller than a wormhole.
Okay.
Probably so small that nothing can even fit through it. Wormholes are different. They're a fold in space that cause a warp that can take you to different areas in space. And these areas, we don't know if it's safe to travel through. We definitely know it's not safe to travel through a black hole because that will disassemble your atoms and break you down into matter.
Not ideal.
What?
Not ideal.
Not ideal, no. That is my presentation on my theories of black holes.